Hello, this is Ravel Nugumanov, founder and software architect at One Way Automation, a small technology company located in Edmonton, Canada. Today I'm going to demonstrate new feature in the Visual Logger for OPC, our flagship product used to collect industrial process control data. A new feature, high availability. What does it mean? Let's say we need to collect data from various data sources. In this case, they are OPC UA servers, and we want to move that data into some cloud-based location like InfluxDB, or it can be Apache Kafka, it can be Confluent, it can be a SQL database, PostgreSQL, MQTT, no matter what. So the task is to move data from factory floor to the cloud. And we want to make this process like highly reliable because sometimes the hardware, the PC, industrial PC or server, where we run the application that collects data and move it to the cloud, we might need to shut down it for some reason. We might to maintain it, or it can be just out of order sometimes, and we might to upgrade it. And for these time periods, we need to make sure that data continues to flow. So for that reason, there is a feature called high availability. And what does it mean? You run two or more uh, nodes in a cluster, so they work together, and one can stay active, and another can stay standby. And if active node becomes for some reason not operational, intentionally scheduled or accidentally, not expectedly, then standby node would take over and continue data flow. That's the idea. In the version 4.2.2 of the Visual Logger for OPC, we did implement this feature, and now I'm going to demonstrate. So what we have a few OPC UA servers and data source, and then we have two instances of our Visual Logger for OPC configured to run in a cluster as a team. And we have in the cloud, at OVH cloud, we have a small virtual PC that runs InfluxDB. This is our destination where data is flowing to. And then we have Grafana to visualize data to see how it goes. And here I have also a PostgreSQL database, instances of the Visual Logger for PC connected to this configuration database. Why? Because they need to share the same connectivity settings as connecting to data source as well as to the destination database. They have to be in the same page. That's why we have the same configuration database. So this is the short diagram. And now let's go to how it's implemented. I have a Rust disk that I use to remotely connect to my lab computers. So this is the server where OPC UA servers run, and I have two nodes, node 1 and node 2. Note that they run different operating systems. One is Oracle Linux, and another is Debian Linux. And you can also mix Windows with Linux nodes and run them in a mix. High availability nodes, they don't need to be exactly the same. They might have different hardware, software specifications. So now if I go to, for example, node 1, what I have here, I have Visual Logger for OPC running in a Docker container, and we have new service called HA node, short from High Availability Node Manager. And we can see that what we have here. I'll provide the link to the repository where you can get these Docker Compose files. One image runs ogamma logger 4.2.2 version, and the second is new service, high availability node manager. And what we have here, this is the Docker image, and we have cluster ID, node ID, and then priority. If both nodes are operational, then the one with the highest priority will become active, another will stay standby. And then we have the URL to check health of the application. Application in this context is ogamma logger. And then we have to coordinate the work of these nodes together, we have so-called heartbeat messages database that is in the same PostgreSQL database. So we have in the PostgreSQL one database to store configuration data for Visual Logger for OPC, and another is used to exchange messages between high availability nodes. And we have also some settings that allowed us to configure how failure is detected. So we have these two nodes, and I have here also a little bit extension for Visual Studio Code to control my Docker containers. Why I use this? Before I was using Partainer, but in this new version of the Docker, it stopped working. For that reason, to control my Docker containers, I use extension in Visual Studio Code. So this is one node, and another node is running Debian, similar setup. They both connect to the same database. And then what I have here, this is the third box where I have OPC UA servers, and also I have web client, web browser to monitor my data. I have just one variable visualized here. Why I have this variable? Because it shows all straight line. If straight line without interruptions goes, then it means communication is going okay, fine. And I have here data value changing every second. If I zoom further, then you can see that every second we have new data value. And now I'll go back to show last 5 minutes. And in this browser, I also have access to configuration web page for both Visual Logger for PC nodes. You can see here what we have, 5 servers, and if I click on the server node, then it will show me 5,000 items, and another one, each server has 5,000 items. They are sampled every second, sampling interval -1 means default equal to publishing interval, which is 1 second. And then here is the total number of items or tags, variables, which is 25,000. And if I go to tools statistics, then I can see that we are connected to InfluxDB, located in the cloud, and it's connected. And we have in the local buffer almost no data, just sub-millisecond duration of data we have, and we have data is collected with read 25,000 every second, and forwarded just a little less than 25,000 because we have a little bit behind, we have some portion in the local storage. That is, and we also can see here that we are active, and here is the node ID and cluster ID. Okay, so this is node 1, and the second node, we have the same thing, but it's not collecting data and it's not forwarding any data right now. It did some time ago, but it was when it became active for some time, but now it's not doing that. So now let's a little bit consider what makes these two instances of Visual Lager for OPC members or nodes of a cluster. The point is that in order to run them in a team, first you need to configure them to connect to the same configuration database. As I said, configuration database should be shared between two nodes. So if we look at this is at IP address ending by 79. Here's the database name. We'll config each A. I have it here. This is the database they are connected both to. By the way, that should be also high availability database. So we have this configured. And second instance, if we go to the settings, connection to the configuration database, it's connected exactly to the same database. It's how they share the same state, the same configuration. And now, next thing is we have so-called collector configurations. And the point is you can configure Visual Lager for OPC to connect to different UA servers and variables on that. And you can switch from one configuration to another. And you can have multiple, and one of them will be used at the same time. So I have here configuration high availability cluster 1, 25,000 variables. That one is used currently with both nodes. And then this is where we store configuration, where we get data from. And the third thing is where we store our data in, where we forward data to. That's configured with time series database connection settings, and the both instances they use this one, InfluxDB at OVC Cloud. And if we open its settings, we have here what we have: the type and name, IP address important, port number important, and we have authentication token, and then we have settings how to map OPC UA server data to InfluxDB measurement and tags. And we can hear this connection, etc. There are a whole bunch of other settings, but we are not covering them here. And okay, so these three components, and then they are assigned to instances. So we can see here two instances. One is this one, node 1 with the home icon here, and second is running on the Debian node 2. So if we look at instance settings, then what we can see here, by the way, collector agent should be enabled, which means we're collecting data in both one, but only active one will be actually collecting data. And this is here we select the same configuration for collecting data. If we in both instances select the same record, then it means they will connect to the same server, and the same destination we select the same destination. It will make sure that they will forward data to the same location. This is how we configure two instances to run in a single team. And if I go to another node, to the second node, then if I go to instance configuration, I will see exactly the same settings. We are connecting, we are using the same collector configuration, and we are using the same database connection configuration. Okay, so now this one is not connected, and to see what is their state, now I open statistics window in both of these instances. Statistics on the active one. This one is active. Second is standby. And now I want to see what happens our data when we fail over to another one. So for that, I'll simulate uh, outage or scheduled outage. I'll stop visual logger container in the active node. Now it's stopping. Container is stopped. And now here what we see is we see a little bit gap. And this is a secondary node. It was passive before standby. Now it's active. And the first node, now we cannot access it because it's not running at all. And if we want to know how long it took to fail over to the standby node, we can zoom in and we can see we missed just one data point, just 1 second. Duration was less than 2 seconds, which is I think pretty good. So this small gap, when there is no data, we have this, and switch over happened very quickly. And now I can go to this node, and then I can start it. And now, do I see any gap here? I will keep refreshing. We again see a little bit data gap here, and again it's not too big. It would be here normally this data value, but it's a little bit comes a little bit later. But other than that, it looks just fine. Okay, and we can check at the GUI now because we did shut down and start again. We have to log in again. And now if I go to the tools statistics, then this one is again active node 1 and this one became standby. I can repeat one more time. I can stop it again, stop it, stopping, stopped, and then see again the graph here. Again, we see this small gap, 1 second, and one data value is missing. I think this is in most cases acceptable because very often our customers they don't have data collected with high frequency. Sometimes it can be even 5 seconds every 10 seconds, and in that case, it can be considered as no data outage at all. It would be considered as a without any gaps. So this is the video I wanted to demonstrate you. Just if you are interested, one more thing. No, this is not that window. So I would like to look at what is the CPU usage. This one is active mode, and we can see it uses just 1 or 2% of CPU, which is not high at all. And how about this one? In this one, we have system monitor a little bit different. Where is our process? So now, right now, because this one is not active, and there is no that process because it's not running at all. What I'm doing. Let me start it now. Let it start. Let it running. Is it running now? So if I go to here back, is it running? Can I log in? Okay, See that it is active. Okay, so now it's active, and the one which was before active now it's that this one is now standby. It's like using 0, and if we go to this one, uh, this is active node, and here we can see 1 or 2% CPU usage. So uh, this is just fine. And I have this I have specifications for these nodes here. They are quite like powerful. They are running on our OBox medium configuration, but not everything from this power is used. We have a lot of room, so you can also collect data from hundreds of thousands points, no problem. Okay. So now, if you are interested, please contact us. Here is the product page. This is Visual Logger for OPC. You can scroll down, and if you are interested, you can get the free community edition. And by the way, 64 variables, you can collect them for free forever. That's for free, and for 30 days it will work just like Enterprise Edition. And there is a Standard Edition you can purchase online, add to cart. And for Enterprise Edition, we uh, quote the price based on number of OPC UA servers and tags and what services are required. Based on that, for that you can get a quote. And here's the link to the user manual. Yeah, this one is linked to the user manual. And here's the user manual itself. You can see how to deploy it, how to deploy it to Windows, Raspberry Pi, etc. And if you have questions, please drop a email or send. We have contact us form here. Send it from here. Or you can send message through this online messaging system from our website, or you can schedule a meeting if you wish. Web meeting, we can help you to configure, to deploy, configure, and answer all your questions. Thank you for watching. That's it for now. So this was one-way automation video about our new feature, high availability, which became available on the version 4.2.2. Today is December 11, 2025. Thank you for watching. Have a great day. Bye bye.